So good afternoon, everyone. So we'll continue on what we stopped last time, continuation of more client-side based vulnerabilities. And towards the end of today's session, I do want to make a few announcements, but primarily this shouldn't take more than 2 hours, I hope. So let's start off with some of the quick basics that we'll be covering. So obviously the note on ethics, as always, I think I want to read it one more time. I think you guys have seen it multiple times, the same slide. For today, we're going to be talking about CSRF. I know we have discussed CSRF before, but we're going to talk a little bit more in depth. And also because CSRF is a bit tricky with respect to where it comes down to, because it could be considered as an injection, but also in one way, it is client side. Ultimately, the person who's being attacked is one of your customers, your clients. So it's more, the attack is not on the institution, but instead on your customers. So we'll be continuing on that. Yes, I know MasterChef. What time does that start? I would definitely want to stop before you guys want to watch that. Like, but I don't know what time it starts. So let me know so that I can finish on time. With respect to, then we go on to clickjacking. We did discuss a little bit. We will go on that and then finally finish it with content security policy. So these are the important things we want to cover. So with CSRF, most of you might already be familiar with it. The aim over here is to essentially trick your victim into making an operation which they didn't intend to, and your backend has no way of verifying whether this particular operation was actually intentionally triggered by the user or was tricked into triggering that. There's no way to differentiate that. So for that to be successful, you'll have to have a few things that has to work your way from an attacker's perspective. One, you need to be clear what exactly you want to do. You want to trick the user to do. So for example, if the intention is to trick the user to change the email address to your desired address, so that's your action that you want to happen. Second, the user has to be logged into that particular application that you're trying to attack. And so which means they should be already having the cookie token, whatever is required to connect with that application. Third, there has to be everything should be predictable. So there should be no special code or token or that is unique to that particular user, which will essentially make sure that this kind of an attack is successful. So typical example of how a CSRF attack works is the malicious link is sent to you, like typically in a phishing mail. And the assumption over here is that you already logged on to Bank of Washington with you have a session ID and so on and so forth. So when this particular, when the user clicks on this link, the link is sent to the evil.com, the attacker's site, and the page gets loaded. When the page gets loaded, you have something similar to the form that you see there, which has a clear indication of that it has to go, it has to make a request to https://bofw.com. And with it, the action that it's going to do is essentially saying it's going to do a transfer amount of value. And in the end, you see a form.submit. Typically goes on to submit this request. When this gets executed in your browser, it's automatically that the data is transferred back to Bank of Washington, which would not be aware that this is actually being triggered by somebody else, but it thinks that's coming from the right client. There's session information available, so it will go ahead and process that request. And that's typically why it's called as a client-side request forgery, because it was not intended, but there is no way for the backend to differentiate it. Now, if you look at the specific payload that we looked at, this is a more detailed view of the same thing. Like for in this example, we are doing a post request and we have a form, we have the information that we want to change. So as soon as any page with this kind of content loads, you get a request that's getting sent across. This is typically the payload as well. The payload is fairly straightforward. It goes straight onto the vulnerable website, and you can see the cookie for that session is attached with the intended email change that you are looking at. So in a simple way, that's what CSRF is, and I think till this point most of you might be familiar with. We'll look at a quick CSRF demo to demonstrate what we just discussed. Hold on a second. So let's look at CSRF. So if you look at a legitimate page from an CSRF thing, is just a straight normal form page which you use to transfer information across to anyone. You put in your BSB, your account information, and what you want to transfer. So let's look at a few things here. So this is a fairly skeleton setup. So if you see the form, it doesn't contain a lot of information. Sorry, a second, I'm just scrolling up and down. Yeah, it does not contain anything more than a simple account information, BSB, and the information that we just put through. So it has no protection whatsoever. So if I have something like this and I do a transfer, this is a legitimate transfer, that's fine. So we can go and have a look at it in like a bank transaction, which pretty much shows that amount has been transferred to this person. So that's the correct way to do it. Now, from a malicious view, all you need is just any URL, and this particular URL just loads. And you might want this is all the attacker is providing, just an URL for you to just click on. And if you go and look at the inspect elements and see what exactly is happening, let me load this page again. If you see over here, there are a few interesting things that happen. There you go. So this is the post request that this page generates on behalf of the attacker for your client. So when I execute this post request, it goes on to automatically send it to its own account information with its details there. So which if I do an update to my transaction, every time I load that page, $2,000 get transferred straight off to that. So that's typically what happens in a scenario like this. So if this is the problem, obviously we have discussed before, it's important to have some sort of a randomized element in this so that it ensures that this kind of transfers do not happen. And the backend has some way of identifying that it's actually legitimately the user that is doing it. So we'll look at the same example, but in a slightly different viewpoint. So if I were to take, say, a more secure version of the same app, and we look at the source code over here. It's almost the same thing, except a few minor details. See the addition that you see over here. This form is the same, but it has generic random token created, and this is unique to this user when the user logs into this particular page. So this is typically what's called as a CSRF token. And and the transfer would be exactly the same, but in this scenario, if the the attacker were to try to submit that similar kind of a request, let's see what happens. You see a 400 bad request because the server was expecting an extra token to come across, but since the attacker would have no way of guessing what the token is, you effectively prevent it, and that's how you get around the situation with respect to CSRF. I hope that makes sense. Is there any questions at this point?
So is the CSRF token kind of generated per login, or Are there different rules for that and different ways you might do that?
Yes. So there usually CSRF tokens can be generated per session for that particular user. On the other hand, for a much effective control, the people usually say you generate per page. So it's not really expensive to generate a token. So even for the same user, but somehow the attacker does get access to the token, it's not repetitive and it does not happen all the time. So every single load, you're going to get a new token. It becomes really difficult to guess it. So there's been arguments in the past, historically, when this was introduced as an effective control, people said, well, that's a lot of computation to generate per page basis. But realistically, in today's modern world, that's not the case. Most of it is pretty much built into the framework. And half the times developers are not even aware it's being done. You just click on CSRF protection and things work for you. So no one is anymore complaining, oh, I don't have to write a whole cryptographic algorithm to figure out something. All this is now auto-generated. So there is no real need to not use it, but often you see cases where people have disabled CSRF because for easiness to test some payloads where they have to automate some payloads and test it, and they don't turn back on. So the config will be set to off. They have everything ready, but the config for the CSRF is set to off. And this is something we commonly find when we're doing pen tests and you realize that it's not there. It's not that it was not implemented, it's just they forgot to log on in. So that's something that from an attacker's perspective, you might want to be aware of. Just because a website is very reputable and you think they should have it, they might not have it in production because it's more a config issue of not setting it on.
I think if you really want to have a play around with this, Python Flask or Python Django really does this really quite well built in. So if you want to have a play around, you'll actually notice that most of the time you won't even notice that the CSRF token is being injected for you into your template, but you can explicitly disable it in some of your applications.
Yeah.
Quickly on the per page or per session, I think most commonly you'll see a single token per session, and the argument is really that back buttons really tend to break quite a bit if you run into like single page tokens. I think that there's probably a different argument to be made for which one is good for which use case. I think it depends on what you're trying to protect, but it's probably good to be aware of that if you do require a different token per request, you need to make sure that your user has made the request for the latest CSRF token before they make the next post request to make a change to an attribute.
I thought CSRF was always regenerated per request. Is that how it used to be done, or is that just not a thing?
No, most frameworks will give you a single token per login session. So it won't. Most of the time, the CSRF token won't necessarily change. Well, it's unlikely to change during your login session. I think times where it will probably change is when you elevate privileges or when you log out and log back in. Yeah.
Okay, so am I imagining it that there's a kind of token where every time you send a request, it regenerates and sends you a new token?
I think I think from a CSRF perspective, I don't see. I'm not sure that that's the value that you're talking about. You might be talking about a different value for Varun.
So there are two aspects to it. It's pretty much a configurable parameter. A lot of frameworks do support generation per page or generation per session. So the argument is back and forth. So for example, if it is generated per session, it could be something that can be embedded as part of your cookie itself. And so that's per the session, and the token is specific to that particular session. There are scenarios in which you would want to put it specifically for pages. It will be different for, let's say, if you're going to do a high value transaction or you're doing something that is a sensitive transaction, you could have a different token getting generated. So there is no hard and fast rule that this is the right thing to do. From my experience, I've seen varied versions of it, from one getting generated just at the time of the session generation, some during privilege escalations or high level operations, or in some cases pretty much a per page generation. And all those things pretty much means you have to maintain that token information in the backend. So that's where the good, positive, and the negatives come into picture of per page generation. That means you have to maintain a lot more information in the backend. But again, it's something that people don't mind doing that. So there is scenarios in which you see typically such tokens being like generated per page and just stuck into some Redis or something that we can quickly check for that particular user. So today it has become easier, but it's very much configurable and it can be done. Yes, can this be, if you put it in the token, can it be stolen? Yes, it can be stolen. That's what we talked about. If you have an XSS or something that's already present, CSRF is going to be really not, CSRF tokens are of not much protection anyway. If it's going to be stolen, the token, it's going to be irrelevant because you're going to be in the local domain altogether. So stealing a cookie will be very much depend upon what flexibility you have in your application and how much you have escalated your privilege within the application itself. And I want to go into quickly to other questions. Someone asked about CSRF token XSS. Yes, that is true. That can be done. Oh, sorry. Can a token, depends upon where your token is present. So let's say if you have an XSS, you really don't care whether you want to steal the CSRF token itself, because you could essentially, like we discussed last week, you could essentially make a request to the backend. Now that you have the session information anyway, and you're in the same domain, you're going to be able to make a request to the backend, get a fresh form with whatever token it comes in, fill it up, and do a post. You can do all that in your JavaScript, so it would not break. So yes, it's irrelevant if you have XSS. Do you have to be on the same domain? Yes, you'll have to be on the same domain to be able to leverage that. Correct. Can I send a evil post request to Quokka Bank using? So this is only possible, like I told you, you are loading a page from a different domain. Yes, but as soon as you load it from a different domain and you're making a request through, if you're logged in, then that particular request will go will be sent out. The response will be blocked. But in your case, again, remember, get and post requests are simple requests. So that means the request would have already reached. In this case, if it is meant to transfer some money, the transfer would have already happened. So it really doesn't matter. Yes, so if you have a HTTP only flag set, then you will not be able to steal that particular cookie through XSS. So that would be one protection that you can have to be able to save yourself from your cookies getting stolen. Is there any more questions? Okay, so that's a good question. Why does cookie stealing? Okay, now this comes to a very interesting aspect of it. How many of you have noticed applications which manage a lot of client-side functionality, like for example, menu, open, close, all this with cookies? Have anyone seen that? You would find that there are a lot of other sorts of cookies out there, not just purely session cookies. And a lot of these cookies can do with your client-side formatting, templating, and different sorts of ways your UI should be framed that can be stored as cookies. And typically you want JavaScript of your own application to be able to make changes to these cookies dynamically. So that means having HTTP only would prevent you from doing it. So what a lot of developers do is they tend to not want to put that header in because it's preventing them from implementing a functionality, something like that. And before long, even critical cookies like your session cookies don't have those flags being set. And that's what happens in many applications. Also, another reality of these sorts of cookies is who's responsible for setting these flags. So some applications might sometimes generate a cookie, but it would expect that the cookie will be modified on the fly by something like a WAF, which will have the necessary headers to be added before it's being sent across. And so they would say that it's not our responsibility to do all that. We just send it across and we have this magical thing called WAF that will do it. Now, if you do not know what WAF is, don't worry. We're talking about that next week. But essentially they expect somewhere else this thing to be modified, and your job is to just generate the session. So there are various reasons why sometimes those flags don't get set correctly. Any other questions, folks?
With HTTP only, that'll still get sent in fetch requests in JavaScript. Is that correct?
Correct. Because that's set by the browser as soon as you send it across. You don't control that, but it will get attached by the to you by the browser.
Yeah. So you only can't view it in the client for handling logic in the browser.
Yeah. All right. Moving on. So we just discussed this. I should come to this slide, but anyway, we discussed the same thing, where the defensive capabilities is to provide something like a CSRF special tokens. It's also really important to make sure that it's randomized. It's tied to user sessions, because you can't generate like hundreds of tokens and not have associated with this particular user. And more importantly, it is strictly validated. And that's important, because just because you have a token does not mean that you shouldn't be validating them. Think of the scenarios where this token was generated for this user, yes, but in a couple of hours ago or in a previous session. And if someone having that same session comes in and just logs in, and in your backend implementation, all you have is a user and a bunch of tokens that were generated for this user. There's no way to know whether this token was generated for this session or not. If you do not have these sort of details, you're going to end up allowing so-called legitimate token that you actually generated, but it's no longer valid. So things that to be aware of. Okay, moving on. Carriage return line feed. This comes with lots of history behind it, and sometimes it's funny, but it's still a thing. So can someone tell me, where does this carriage return line feed come from? What's the background behind it? What is it, first of all? Or what's it used for? Yes, that's typewriters, that's right. Yeah, no, typewriters is the right example. That's where it started with, the historic reason why this exists. So they are extremely old technology that's been used. I think I may be wrong, don't hold me to this. This is based on my reading somewhere, that carriage return was originally used by DOS, and so Windows continues to use them today. I may be wrong about it, but that's my
that's correct. Windows does carriage return line feed.
Right.
Linux just does line feed.
Right, correct. So the Unix systems have always used line feed for quite some time. So you might actually have scenarios like, if you use GitHub across Windows and Linux platform, unless you configure specifically to say, have a commit depending upon the operating system you're using, the right kind of controls that you need to put it in place. So it's quite interesting, old concept that's still relevant. Now, obviously we are not interested in text files and stuff like that in this discussion. We are more interested in, obviously, HTTP, and as someone said, HTTP headers. So let's look at what is the use case of this in today. So if you look at a typical post request that goes through, which has a header as well as a payload along with it, the differentiation between the header and the payload is done by two lines, two empty lines. So typically represented by /r and /n. That's a way to know that that's one line, and then these special characters, non-printable characters, that gets understood as extra lines. So this is commonly used in your HTTP headers. So now that we know this basic concept, now we look at how this can start influencing in which in a way our headers behave. So for that, the first and the most important thing to understand is redirect. So I'll give a simple example, and I kind of wanted to see if I have a demo. I didn't have a demo, but I had an old CTF that I did long time ago. I want to show that as a demo. Maybe it may or may not work. I didn't test it much, but I want to showcase what it is, because you want to understand first and invalidated redirects. So which means the most important thing is if you experience a scenario or a web request in which the URL to which the application has to redirect to is controlled or controllable by the client, and then it's not validated by the server on the back end, tends to become an invalidated redirect. I'll give an example. In this scenario, in example.com, the client seems to be having control over something called dest, and it's just a parameter which seems to have the URL to which the redirect has to happen. Now, if this were to go to the backend, and the backend is looking at the dest variable, it has to do some sort of validation against it, because if this is coming from the client side, then it's client controlled. That means it's an client input or a user input, and so it cannot just take it for face value. But again, we see plenty of times when this is not getting validated and the redirect automatically happens because the server assumes that this value is not tampered with. So in that case, it just redirects you straight from a legitimate site of example.com to evil.com without you doing much around it. So that's typically what's called as an unvalidated redirects. So I'll see if I can do this as a little demo. It may not work, but let's see. This should be. So take a scenario, something that looks similar to this. This is like an authentication system that you want to connect to. So the moment you do a call, so there are a few interesting things that happen. So you need to look at what's happening over here. So it seems to me that at this stage, there is an URL request that's going out when you have to log in, and let's see what this does. So it looks like it has a token that keeps showing up. So we'll if you go and try and decode what this is. Okay, so let's first decode them. Okay, so it's pointing to an URL over here. So that means the token or that encoded value is essentially an URL piece. So if there is an URL piece around, so I can see if I can modify this data, and if I can modify this data successfully, I will be able to have a successful potentially it's possible that the backend may not validate this. And if that is possible, then I can make it redirect to anywhere I want. That also means that on success of that login, if I have the token ready, it seems to that after the login will take you to blog loggedin.html. And that's typically what's happening over here in this scenario. It takes you to blog loggedin.html. So what I would try to do is now just make this into, say, google.com, and that's the encoded bit. Now, what I can do, yeah. Can just replace this and I hit that, there you go. So essentially what this does is it just allows the redirect to be successful. Obviously, in this case, I do not want it to go to google.com, but where we just send it to give a flag or something. But otherwise, typically the scenario is to show that how a client controlled parameter can be modified and the backend does not validate it, assumes that whatever has been sent to it is intact. But as you can see over here, that can be changed. So that's typically what an invalidated redirect is. And the reason I'm bringing that concept into this discussion is because it will be quite useful from where we are, and we can start to see some examples of what's happening in this case. So response splitting is one of the common things that you see when you deal with /r/n. So as we just discussed, the most important thing to do is we are dealing with HTTP headers, right? So if you're dealing with HTTP headers, you have to have a scenario in which some user controlled input, it seems to be getting reflected into the HTTP header responses that's coming back. So that's your prerequisite to be able to succeed in this. So in this scenario, in this simple example, the variable u is essentially whatever value that is being passed into this parameter u seems to be used directly in the backend to update the URL location. So the location header has this value URL that seems to be taken from directly the user input that's coming in. So if there is a scenario that happens this way, you essentially can start to put /r/n and then continue to add more headers, and you can even add HTML code to it. If you say, take an example over here, if someone adds content with these kinds of extra characters around it, you will see that the response will come back with location truncated, and then your content will now call it as text.html, and then you can actually have a full HTML page put up over here, and which means you have pretty much terminated it. Now let's see how this actually looks like. In real life, if you were to implement this, you would end up with something that looks like this, where the response is coming back with a content location is /r/n, which means it's not printable. It goes to the next line, goes ahead, and you determine that it's actually a text HTML file, and then you do a double /r/n, which pretty much says that's the end of the header, and then puts in the HTML that you want. And whatever the other headers that were originally part of this request, they all become data to this. And so it really doesn't matter. It's going to show up towards the bottom of the your HTML as some text. So this way you can pretty much inject HTML contents or scripts or whatever you want into this by splitting the header into two and inserting an HTML to trick the browser into loading that. So this is a common scenario that you see where the backend is not necessarily taking care of these special characters being injected into your header. Now, we looked at it with respect to redirects, but do we really need redirects for this to happen? So that's an interesting question. For some reason, pretty much everyone talks about this kind of response splitting with respect to a redirect. So I want to just showcase that it's nothing to do with redirect altogether. And so it's something that we could look at it without that context. So let me show you a demo. So I just wrote this as a quick demo to just demonstrate this. So it's obviously not a properly written demo, but it will get the point across. So that's the more important thing. So let's have a look. This I'm just hitting this particular page, and I have an URL which has a parameter called item. I can just put any value I want over here, and I want to see if this value is getting reflected or has any way to contribute to the header. So if I hit and have a look at what's happening over here, I can see that the value that I'm passing here seems to be added to my location header. So it has some sort of an impact to what's being sent across. So the moment I see that some user input can have some interference with the header, I can see potential issues that I can do. Like for example, have a look at this one. I take a simple scenario as what we talked about. And instead of just setting some random value, I do a set cookie. And that means I could actually set my own session tokens over there so that I can pretty much take over a session with the token of my desire. So if I want to do that, I can, if I do simply this, you will see that I managed to basically break out of that and do a /r/n to this. And it will actually go ahead and create a separate header called set cookie, and where I can actually go ahead and set a cookie of my whatever that I desire to. This is also one of the different ways in which you can exploit headers like this, which could be quite significant when we're dealing with scenarios like this. Now, the question you might have is this still a thing? Now, that's a good question. And I have my personal views on this. So what majority of the servers and frameworks that we see today take care of this automatically by themselves. So that means if you try to inject like what you're seeing right now, it most likely you're going to see that the backend will determine that, oh, there is /r/n in a header variable, and it's just going to truncate it or throw an error, or it might just remove those special variables altogether. But that's not always the case. So there are scenarios in which there are middlewares that can cause quite a lot of havoc. Now, I'm not sure of how many of you understand the term middleware, so I will just bring this point to what it does. Some web services or servers provide capabilities like hooks, where every time a packet comes in and processing is done, like a HTTP request comes in, the moment a request comes in, you can have a hook where you can register a function, or you can register a library to be able to take over the request that has just come in, modify, do something, and send it back to the server, and then continues to process. These are called hooking in your web servers. When you have these web hooks that are available for you, that's not the right term to use, but typically processing hooks, a lot of middlewares can sit into it to better look at your server requests, see if this request needs to come through. Typically, a lot of security toolings can plug into this at different points within the server's processing. And when you have things like this, these third-party endpoints can bring about injecting these sorts of unnecessary /r/n or vulnerable to something like that. And when they write back to the servers may not necessarily verify the data that has been written by these, because they're supposed to be trusted modules that are connected to your web services. So anything that's coming out of this is considered trusted data, so it may not necessarily revalidate it. And in the past, there have been scenarios in which some of these middlewares have been causes for issues that you see over here. This example itself was harder for me to just demo, because this is, you have to come up with a right set of circumstances to get these working. So for this demo, I had to actually pick up an older server, which there was a Node.js server which was not patched, and it had these issues before, which they've patched it now with the latest newer versions of it. But it had this issue that we could pretty much leverage and use it in that to just demonstrate to you. So when you experience this in the wild, do try it out. Don't be assuming, oh, this is such an old bug, it may not necessarily happen. You might encounter them, and it's not surprising to see them in the wild. Does that make sense? Are there any questions on this? I see some questions. I don't know that I have answered them already.
Hey, Varun,
Yeah.
I was wondering if you could drill into a little bit more detail on how setting a cookie would work with session fixation, and
Yeah.
end to end of how you'd actually use that to hijack somebody's session.
Okay. Actually, I think I have that.
Okay, cool. I just thought it flowed naturally from what you were saying.
I think now that I think of it, I should. I don't know why I split that across into another session. I actually have a flow of this into that. For some reason, I don't have the slides here.
It's okay.
I wanted to talk about session fixation. Why should I bring it up here? Let me do one thing. I'll talk about session fixation if I can pull up those slides little after I finish this flow, and I'll just continue from that point.
Cool.
Sorry, I was trying to figure out, was there any question? Okay, I don't think I saw one. Okay, moving on. The next one, clickjacking. So we talked about this, and last time when we discussed clickjacking, I remember we had like a lot of questions about it. So I do want to talk about this. So with the time in mind, I know we haven't done an hour yet, but I think this will be a good time to take a break and come back to this too, because I'd like to have a continuity rather than it. And meanwhile, maybe I can figure out if I have the session fixation thing somewhere and pull it back in. So it will be a good time for me also to have a look. So I will say we'll go for a break. We meet back at 6. Is that okay? Perfect. Thanks, guys. I think I'm still sharing my Zoom. So if you're able to see if me going back into presentation mode, it's probably not frozen then. The last demo, okay. Actually, that's something I can do. Sorry. Okay, where were we? So, sorry, in case others are wanting, some people want to see the demo one more time. So I'm just going to repeat it. So the prerequisite for something like this is the need to have a user-controlled input that can be reflected in the headers from the response headers coming from the backend. That's your prerequisite over here. So in this scenario, in this demo, I'm just providing some input, and I notice that the response that's coming from the backend seems to add my input into the header, so that that means I know that any input I provide over here will come back to me from the server. At this point, obviously, I do not know whether it will be validated by the server in the backend, but I do know that it's getting reflected. So if I were to provide an input, that's a slightly more interesting, where I just say the input to have a set cookie. And if you wonder what these are, these are just encoded URL encoded characters of basically /r/n. So if I were to take this as the parameter, as the user input, and see what happens over here, you can see that the response is now coming with the set cookie. So, which means this is something that I controlled, and I set a cookie over here. Now, how will it be from an attack perspective? As an attacker, I can pretty much set my session token or token of that is of my interest into your application. And by doing that, I can essentially fix that particular session to my interest, and then make you perform actions that will work comfortably, because I already have hijacked your session with my own session token there. So that's typically what you can do. Once you're able to set a cookie, you can do quite a lot with it. So that's one of the primary reasons this is considered dangerous, because you're allowing, you're leveraging a scenario in which you're able to put a user input straight into a header. Does that make sense? Did it clear it up for you? Cool. Slides. Is everyone back? Okay, so
I'm here.
perfect. Let's do it now. Sorry, I was trying to get some of my slides on session fixation during this break. I could not find them, but probably I will talk about it nonetheless because we are anyway at that stage. It kind of makes sense. I don't have any slides for them though. So at this point, I just want to bring about what we just saw of a set cookie scenario that we just seen. Why do we need that? So there's a concept called session fixation. So unlike what we like to think that all applications tend to be very extensive with respect to making unique sessions across for each user, uniquely maintained, that it will never be repeated again in any other scenario. It's and once created, once destroyed, it's never going to be reused. The reality is far from true. So you have applications that tend to have a valid sessions definitely generated, a unique session generated, but it's not necessarily attached with respect to one particular user alone. It could be reused again, or it could be attached to a particular user, but there is no specific information that this is the user who just logged in. So the session IDs are kind of like unique, but not necessarily unique to the user. So in that scenario, you can leverage attacks like this, where if you do a set cookie and you have that one of the unique identifier to be a logged in application user to that application, you can pretty much get set that session of your desire into the user's browser, which is what that particular demo is showing. And if the user, when they continue to browse, they would be using that particular session to continue with their rest of their authentication authorization running around with it. But now that the session is a valid session and that's being used by the user, the same session ID which was set by the attacker can be used to impersonate the same user, and they can go ahead and continue to impersonate and do actions as if the user is doing. There is no way to differentiate between the two users. So typically it does not say, oh, one user's who's logged in seems to be coming from this IP and another user is coming from a different IP. It does not differentiate it, simply because sometimes it's not possible. It might be that one might be coming through a VPN, one logged into the same browser. You might try to disable the VPN and come directly through it. So there is no way to differentiate whether based on IPs to say that whether the same session coming from different IPs is dangerous or not. So most applications don't have that sort of controls. They kind of just let anything in. It doesn't care much about it. And that's typically a kind of attack that you can leverage in session fixation. Having said that, that's only when you have vulnerabilities where user sessions are pretty loosely coupled, but not necessarily very tightly to a particular user, very unique. That sort of controls can typically prevent session fixations from happening. Does that make sense? Silence. Okay. All right. Let's move on to clickjacking. Now, I find clickjacking as an interesting form of attack, and I was pretty surprised a couple of years ago to see some Google presentation which said clickjacking is pretty common form of attack, and I always personally I felt it's not that common a form of attack. Even if it is done, it's pretty badly done, and you can identify them. But
can you full screen the presentation, please?
Oh, sorry.
Thank you.
No worries. So, but that's, but I've seen over the period of time that my personal opinion is different from what actually is happening. So it looks like we have to cover it and or know about this, because it's a very useful and a very good attack if done correctly. So the premises of clickjacking is essentially to trick a user to click on something which they think, trick a user to click on a button or fill up some details, but the action that they're performing is not what they intend, what their UI is showing them to. So that is something similar to what we saw last week, where we showcased a scenario in which XSS jacking, where we showed how we were able to send data across the from the client to the from the client to another different session by just a kind of copy paste scenario. And this is exactly that. And that time there were questions people were asking, how do you induce an action? What if there is a button? I know not all of you were there in that session, but I'm going to talk about that over here just for those who had those questions at that time. I didn't answer the question at that time. So for this to happen, you need to have really good CSS skills and to be able to manipulate the UI to look like a legitimate UI. So that's the prerequisite. Another important factor is iframes. Iframes, for those of you who asked what it was, so iframes is just another attribute, I think it's an element in HTML, which allows you to frame web contents from one page into the other. So like say, for example, you have your home page and you are a big fan of, say, I don't know, some news channel or a URL that you really like. And in your website, you want their news to be showcased in a section of your web page. You can do so using iframe. So it's a legitimate function where you can frame another website inside your site, similar to how you do YouTube videos and so on and so forth. So iframes are really effective means to do it, but then they can be used in attack scenarios as we will see now. So when this started to come about, there were barely any protection against it. So if you are able to successfully place a fake image or a fake like a legitimate application and then put a fake application behind it, there is no way to know, because there is no control over what iframes can do. If you can play very carefully with your iframes, then you can do quite a lot with how you design and how you make it look legitimate. So at the initial way people try to tackle this problem from a defense perspective is using frame busting. So frame busting became pretty famous, because all it does is the way it prevents it is just goes through your HTML page, and anytime it finds there are iframes there, it looks at an iframe settings. So it looks at the CSS settings with respect to this iframe, how it's being framed. So anytime there is an iframe that is trying to overlap another window, or it is made to look, say for example, opacity is set to 0, so it makes it look invisible. So all these kinds of tricks that you do along with iframe is exposed out. So if you make something invisible, it makes it visible and it looks like an ugly broken UI. And any user of that will look at it and say that looks quite dodgy. They wouldn't go ahead and do anything, would not press a button or would not engage with that website. So that was how it was typically done. It was quite effective. There were some common frame busters like NoScript that are quite powerful, and they could just go around looking at iframes around it and see the settings around it and expose them if it looks a bit hidden or dodgy, or any hidden iframes are made to come in the forefront so that you know there are some hidden iframes there. But it's not always so easy. For multiple reasons. For the frame busting techniques were different. Every browser implemented them in their own way. Every plugin, if you install third-party plugins that did that, they implemented their own way of doing it. So which means that you are going to have different platform implementations. So an attacker could leverage one platform and be able to trick a certain browser to do it in a certain way, and then trick another browser to work in a different scenario. Similar to exactly XSS when we saw in Chrome and Firefox, and how their own internal protections failed miserably because they were their own implementation, not a standard. That was the same scenario over here. It was pretty much a Wild West. Everybody had their own techniques. There was no standard around it. Another important thing to understand is frame busters work as JavaScript. So these are your good guys, your JavaScript good guys that goes on to do this job for you. But if you disable JavaScript in your browser settings, that is nothing that you can do about it, because these good guys or the good JavaScript will not have much access to it because it's been disabled. And besides, there's also other features that came with HTML5, like for example, sandboxing. So with sandboxing, you can have certain permissions. You can say that no scripts allowed inside this iframe, and effectively stop these kind of frame busting scripts from exploring inside your iframe what you have set and what you're doing around it. And that's typically a biggest pitfall of something like frame busters. It's still used. I'm pretty surprised at the number of people that continue to use it, but it's not a very effective means to stop this kind of an attack. In other words, clickjacking is also called as UI redressing, and for a reason, because you kind of morph the UI to look like something else for the user, to trick the user into clicking that. That's the premise of this whole clickjacking scenario. Now, from a defense perspective, the way you deal with it is to take a step back and say, hold on, let me not try to fight these frame-based things, because this is a very difficult fight to solve. So instead, the more better way of doing that is for the origin site, which can determine whether that particular site wants to be framed or not, or if it wants to be framed, where can it be framed. So let's say you host a legitimate site, or someone hosts your favorite news sites. And if the favorite news site company, whoever is owning that, decides that they do not want their site to be framed into anybody else's website, they can determine to say so by using headers like xframe option deny. By setting a header like this in their backend, nobody can frame their content into their own pages. So this way you can make sure that people are not being tricked into putting legitimate contents into an illegitimate website where people think that it's actually legitimate stuff and go and click on it. And when people see trusted brands like BBC or something, people tend to think that it's legitimate. But if I can just frame BBC content, real life live content on my page, and then have some dodgy stuff within that page embedded, which when you click on it thinking that you're accessing BBC site, you might end up clicking on something that you didn't intend to. So BBC can decide at this stage, say, okay, I'm not going to allow any of my content to be used, and they can just go ahead and set something like deny. Or they can also have other options like to say, contents of the frame of the websites can be framed as long as it's within the same origin. That's also possible. And finally, you can also say what are the other sites who has authority to frame your contents in. That also could be passed on to it. So it's pretty much up to the content creators, that is their own websites, to decide how, where, and how their contents can be framed. So that's unfortunately getting deprecated. We'll see why and how it can be done in a few minutes. But to be aware, this is still an option that is available for those of you who want to do this. Yes, this is a browser level control. I'm just reading the questions that came in the bottom. The browsers typically look at the content, and when you say a frame and you say the content of to fetch from a specific location, it will look at it and say, what are the headers that are coming back? If the header says you deny, for example, then it's simply going to not load that content over there and just going to fail there. So that's an effective control around it. I'm just going to show a demo of this so that we'll see it in more details at that stage. Sorry, before we go into this, I'll demo, which will probably make things clearer, I think.
I had a question.
Yes.
So from what I can understand, this is basically just phishing.
Right. It is.
Is that correct? Or is there something more to that than this?
Okay, there are two things. So let me answer your question once we do this demo. Maybe you will already get it, or I'll answer you as soon as we do this demo.
Okay, cool.
Cool. So let's have a look at this. Now let's consider this site to be a legitimate site. I know it doesn't look so, but let's assume. Look, I'll be honest, I'm not very good with HTML as such. I tried my best to make it look legitimate. This is the best I can do. So I'm not a web developer, so this is it. So in this scenario, if someone were to visit this legitimate site and they want to donate money, sure, they can just go whatever they want to. Let's just start with no one donates that much. So something really doesn't matter. So when you make a donation, it's legitimate. You can see a transaction to say where it's going. You're doing like $100 to children's charity. So that's your donation. So this is a fairly straightforward scenario. Now, if you look at a malicious page, now you pay attention over here. Now, the URL over here is slightly different. So we are assuming that this particular URL is from a different site altogether. So it's like it might have a URL that is very similar to this charity, children charity URL, but it's not the same. It's a different company. But to make it look legitimate, this content creator, whoever made this page, has decided that they want to frame the contents of what looks like the legitimate site here, that is this page, and make this look exactly the same way. Now, have a look at this. Now, let's look at what is being done over here, and that will give you some indication. So first thing, sources. Now, first, quick, sorry, where's the elements? Let me load this site. Sources should have. Okay, so I'll come over here, and if I were to break this down, if you see over here, there are two frames. That you see the second frame, and you see the first frame. Now, when I move to that, you can see the frames, right? So this is just an example. So this is the first frame that I'm using in this application, and this is the second frame I'm using in the application. Obviously, the second frame looks somewhere in the bottom, but what is more important is the first frame is the content where it's coming from. If you look at the source of this iframe, it says 127.001.5001. That's our legitimate iframe, and that's the legitimate content. So I'm pretty much overlaying the entire content of that web page over here, but I'm putting a second iframe in here that seems to be sitting just underneath the original iframe that came from the legitimate site. And this one contains a different one called clickjack exploit HTML. That's what is framed over here. Now, what makes this even more interesting is to see the styling. So if you look at it, the styling, the CSS that was being provided to me has a very important setting, opacity. That has been set to 0. So if I were to go to that value, I'll show you what exactly is happening here. Now I'll set this to something else other than 0. Let's say set to 50. You see over here, the button is now replaced by this. So essentially, this is the original button that I want you to click on. But I put the donate button that belongs to the original site, but I'm overlaying it with this donate button. But the way I don't show this as donate to Fancy Bear button showing up over here is by controlling the opacity of this particular web page. So if I go over here and set this back to 0, looks beautiful. So, but when I click on this, I'm actually donating straight into a website that I did not intend to. And that's typically how you trick your users into thinking that they are in a legitimate place and everything looks good. And more importantly, the main difference between a phishing site and this is phishing, true, but the main difference is that the content. Now, if you want to replicate, say, a news site on your thing, you have to keep constantly updating it. So no one will believe if your contents are not up to date. But by this, when you put the iframe over there, you're going to get the latest content as it shows up in the site. So you don't have to recreate anything. All you have to do is the places that are sensitive to that website, like the donation place, is where you can place your own donation button underneath it, which you can leverage out from your website. Someone manages to go into sites like this. So for example, mistyped sites are a very common example. When you type google.com, and sometimes you tend to have something else.com, which has a slight typo, and that'll take you to an actual legitimate site. That's how these attacks happen. Smallest of typos in your URL, or you can use something like with your encoding techniques. A Unicode can be used into tricking to have a very similar type URL, and the URL looks the same, but it's actually a different character. Will take you straight into this website that looks exactly the same, and you will have no way of differentiating them. And in that scenario, you can pretty much trick people into clicking on this button. Now, going back to XSS jacking we talked about last time, that's how you would do it. You would essentially have to have people fill up the values that we saw in that example. And if there was an action button that needed to be done, you just need to overlay the action button the way I did over in this example. And you can just replace the button in that form with your own button that belongs to the previous form with iframe. And that's pretty much all you need to do. And the other big advantage is, again, remember it's iframe. So when you click on this button, it's like you're actually having the other site here. So which means if you've logged in, you have a cookie, you have a session established, all that will work perfectly well without any problem. And that's why it's extremely effective solution if you can come up with a more realistic version of the website by doing something similar to this. That brings to another important thing. The button that I showed now this one is not a responsive site because I did not have the time to do one, or probably not very good at doing one. But actually the way most people do this is write a more responsive site, which will change in mobile or whichever. And the iframes button will get redrawn. The one that you saw, the ugly button that showed up over that will get redrawn automatically on JavaScript based on the resize of your window. So that also can be done. So these are the typical ways in which it's done, where it's really hidden very carefully with the legitimate action. Does that make sense? Did I ask questions? Let me look at it.
I just want to quickly jump in and maybe answer the question that Evan asked, if this is similar to phishing. So click jacking or iframe injection basically helps you to do phishing in a better way, but it is not necessarily phishing. The reason I say this is, like, say if you had like a Facebook login page, username and password, right? What if you could load just the username and password field, like just that frame in another iframe on a different website? So it could look slightly more believable. So that's why click jacking would help you to do phishing in a better way, but not necessarily just phishing. Another example could be like if you're going on e-commerce websites and you're trying to process a payment, right? Now there's a small iframe which shows you, hey, enter your credit card details. What if that frame was vulnerable to click jacking? You could take that frame and put it on another website, or you could inject a malicious JavaScript and you could make the JavaScript to sit there on the payments page and basically do credit card skimming. Now, if it was not being loaded in an iframe, then obviously you would not be able to get that data. But because on a payments page that was like vulnerable to click checking, it now allows you to like have a JavaScript file basically sitting there and listening, and then being able to like skim for credit cards. So there are like multiple applications. So click checking by itself is not necessarily a high or a critical vulnerability. It probably falls under the category of medium/low. But still, you have to make sure you fix it so that people can't use it to chain it with other vulnerabilities.
Thanks, Abhi.
Thank you both. That was very helpful.
Is there any other question? Okay. So moving on. I hope that kind of gives an understanding of what it is. So let's further move on to, is it, okay, so finally, the last topic. Okay, how much time do I have? People want to watch MasterChef Australia final. So do I have time? Yes, no?
Wait, is the grand finale today? I thought
Yeah.
MasterChef grand finale is only on Sundays.
You have, you have an
Yes,
hour.
we've got time. This is more important than MasterChef.
Okay, I got an hour. Great. All right. So let's move on. CSF, so CSP. Now this is a defensive control. Now we've talked quite a lot of attack-oriented things. So let's look at some defensive control. And CSP is really, really crucial and important. And for me, I like to specifically promote this a bit more simply because we find it really difficult to convince our existing developers to start adopting to CSP. That's because of what we're going to discuss right now. You'll understand why. But as budding developers, if you guys end up in being developers at some point or in the defense side of it, you might want to be very clear with what CSP is and how it works. I think currently it's, if done correctly, is probably the most effective extra protection that you can have against it. Now, before I begin, I just want to be very clear. We saw excesses and we saw all the defensive measures for excesses and how to write secure code. We discussed all of those things, secure code patterns and all that in the previous session. And by no means is that any less relevant because of CSP. CSP is only an extra additional layer of protection that you are building in. It's defense in depth. It's not an automatic control that will take care of all your problems in the code. So be aware of that. I'm just saying that as a start. Okay, so when it comes to CSP, what it is essentially another security header, yet another security header, but people say that this was ultimately like one header that will pretty much take care of everything else. One header that will take all the older headers, merge them together, all the features in one place, which is pretty good. But CSP has in the past been difficult for a lot of people to implement and often badly implemented as well. It's not necessarily a simple header to implement in most scenarios. So if you take the way CSP works, it is something that works with respect to how each component of your web page is loaded. For example, scripts, images, these are resources. So where are they loaded from and how are they loaded? What capabilities or what they can do is what CSP is. It's sort of like a fine-grained control to every resource in your page. The moment you bring that kind of fine-grained control, you can determine the effect of a particular page or a component of the page and how it interacts with other components within the DOM. And that is effectively a very good control against something like clickjacking that we just saw, the iframe interactions that we're talking about, or XSS injections. So definitely these are something that one needs to be aware of. CSP as a head is more commonly known as an HTTP security header. But again, the good thing about CSP is it can be delivered through your HTML as a meta tag. That's another way to deliver it. And also the more important aspect of it is you can also deliver it in a non-enforcing mode. That is through just purely reporting capabilities. That means if you set your header to report only, it will not prevent any attack from happening in your system. It will just report after the attack has happened. It's always not a bad thing because it also simply means that you want to see how well your CSP policies are, and then you can go on to improve your backend scenario. But this is only, in my opinion, should be only used as a stopgap before you stop to put it in more enforcing mode. That is the actual CSP header. So let's start with this very simple thing. What does the default CSP looks like? And default CSP is simply default source self. Now we'll have to see what they are. What does it mean? But pretty much every CSP headers comes with something called as directives. Now, directives are components of a CSP header that determines which part or which aspect of a web page are we dealing with. Are we talking about scripts? Are we talking about images? Are we talking about DOM interactions? So every aspects that we deal with, like fonts, for example, all these simple small parts of a page can be called as a directive. By default, all directives come under something called default source. And if something is marked as self, that's a directive for which the value that you set is self. Pay attention to those little small single quotes, because those are the format CSP follows. When you set that, it typically means that all your scripts, your images, your style, CSS icons, anything that you're loading should only be from self, that is from your same origin. The moment you load from any other origin, CSP will simply refuse to load those resources for you. So that is your default set. If you set something like default to self, this is actually for such a simple line, it's a very effective control. But we will soon understand in future, but it may not necessarily be very effective, but it's definitely a very good start. Now, the CSP also has capabilities of breaking this down into smaller components. So for in the second example that you see, the granular version, you see the same content policy, but now you set default source to none. Pretty much means I do not want any resource at all. That's what it means. Pretty much means no images, no scripts, nothing should be loaded from anywhere. But then followed by, if I start to put more smaller specific details, like for example, script source, image source, style source, so that they're automatically the lower directives that has been determined, the lower level directives take precedence over the upper level directive. Like the style script source equal to self will take precedence over default saying no download of any style scripts. But over here, I can do that. I can say CSS can be downloaded, but it can be only from self. So there is no difference between the first policy and the second that you see, but I'm only pointing out to the fact that there is a hierarchy to be followed, by the lower level directives take precedence over the higher level directives. So that is something to be aware of. So that brings to another aspect of CSP.
There are just a few questions for Ring. So the first one is basically with the header on your previous slide. So if you just go one slide back, does that basically block you from including any script that is being fetched from an external domain?
Correct. Anything outside of your own domain is not allowed. So that means the self also takes care of, if it is anything from a subdomain, is a different origin, so it will not happen. So it has to be only from, it's a very strict rule in that way. Typically, most applications don't work this way, but think of it. If you have a web app, all your images, scripts, everything is hosted in your actual web app in the same domain, then this will work perfectly, because you don't need anything from externally. So you don't need, I don't know, Minify or whatever. You don't need any of those JS files. Everything is hosted locally, and that's pretty much what that means.
Yeah.
That's a question.
Yeah, it's a great way to kind of fully restrict what you can pull JavaScript from. Hey,
right.
I think the next question is, can you introduce multiple instances of the same header? So can you have multiple content security policy headers? Or how would you address that if, for example, one of these attributes need multiple values? So you want to include a script from one domain and include the script from another domain. So you kind of want to whitelist Bootstrap, and then you want to whitelist one of your subdomains. How would that work?
Perfect. Let me hold off on that, because I'm going to cover that in a minute or two. Is there anything else at this point? Anything else?
Yeah, and the last one is basically, are there similar workarounds to this as there are in the same origin policy, such as JSONP?
Yes, there are. We will discuss that as well. We'll talk about there is goodness, badness of CSP. We talk about everything that needs to be covered under that. So let's let's get into the details. Okay, so the most important thing at this stage, obviously we decided that it's too restrictive to say do not download from anywhere else, right? So there are two approaches that typically we take. One, you can whitelist. Typically say from this particular URL, you can download all the JavaScripts, and I know that URL is safe, it's controlled by me, so I'm going to whitelist this particular URL. That's one way to say. And that means by providing that URL in your CSP header, you're saying that anything from self or anything from this URL or this URL, and you can just go on with the list of URLs, and all these URLs, you can download JavaScript. Or you can go ahead and specifically say from self or only this JavaScript from this whole URL. You can give the entire URL path, safeurl.com/js/abcd.js. I want only that. That's the only JavaScript that I trust. And you can give to that point. You can whitelist it any way you like. And you can say, oh, these are the whitelisted ones. So think of it from your from an attack aspect. So for performing an XSS, you need to be able to inject a JavaScript into that, and you want to get it executed. Now, from a defense perspective, you do not want any JavaScript that you do not trust to get executed. That's the battle we are fighting over here. Attacker wants to execute any JavaScript. The defender will not want anything other than that. Now, how do you determine which are the things that you trust, which are the things you don't trust? So you have to come up with a way, and the one way is whitelisting, which we just talked about. Another way, which is more common and more better way of doing, is using CSP nonce. So nonce is nothing but a randomly generated value. Now, this will take you straight back to CSRF, and that's one of the reasons I brought CSRF into this whole discussion, even though we discussed about it before, because you start to see that the whole concept of security just revolves around the very similar concepts. It's just taking different terminologies, but it's all back to the same thing. We're once again doing a base 64 encoded version of a randomly generated number, which makes it unique to that particular request. And so that whatever you're generating, your CSP header has a CSP nonce, which is the random value. And that can be effective if you include in your page, wherever JavaScript you're executing, either you're loading a JavaScript dynamically or the JavaScript is within your page itself, like a static content. You can simply specify, as you can see in that example, where if the nonce value is present in the CSP header and the same nonce value is also present in the script, it will execute. If the nonce value is not there, the script will not execute. So this means if you're doing an XSS injection, similar to say reflected XSS, you are trying to do script alert one, something like that. And that won't execute because that script does not have the nonce value in it. And you wouldn't know, or you wouldn't be able to guess the nonce value if this is dynamically generated from the backend. And that's typically a very effective control. Another thing to be aware, a typical common pattern is, this is the ugliness, in my opinion, of JavaScript. A JavaScript can create another script. That's what JavaScript is all about. And a lot of libraries use that, where they use a create element and create another JavaScript. So one JavaScript that you trust will create more JavaScripts that it will load into the DOM as it goes through. Now, you can't start to restrict every one of them. If it's dynamically getting generated JavaScript, you can't have nonce values in them already predetermined because you don't control it. It's getting generated dynamically in your page. In those scenarios, you use something like strict dynamic, which typically says to the page that this particular page got loaded and that has a nonce values. That means I trust this JavaScript. And if this JavaScript goes and creates other dynamically generated JavaScript, it will go and it will allow it to execute because it's a trusted script that's executing. That's the way CSP nonce works. That gives far more flexibility into modern way of how most frameworks work. And it's not very restrictive. So nonce is a very good way of dealing with that scenario instead of whitelisting, which can be tedious. And we'll talk about this in the other session, what all the problems you have with just whitelisting it. So this will be a more effective way to deal with it.
Just a question.
Yes.
The nonce, who is the nonce generated by? Because it seems like I would think that you can't import any scripts from anything other than your own site because you need to know what the nonce is.
Right.
So you can't import the nonce from any other site.
Okay, so that's a good question. Let me be, so nonce is generated by your backend. So when you render a page, there are two ways you can put a static script like you see in this example where script nonce equal to and kitten something, that's a static script. Or your script can be loading from say, I don't know, jQuery dot something, right? So, but if that value that you put in your script tag where script source equal to something, nonce equal to some value can be generated by you. So when it loads from jQuery.js, it'll only pull that JavaScript into your page when you have a nonce value. So that means at the time of your page generation in the backend, you can put all random generated nonce value in all the placeholders of wherever you're calling JavaScript. That's pretty much what it does.
Okay.
Yeah.
And the jQuery would have to be authored by you as well because you would have to insert the nonce into that.
No. So you're providing source equal to the jQuery URL, right? And then you're providing the nonce. You're authorizing the fact that that jQuery URL that you're provided, the full URL to pull the JavaScript was authorized by you. So when you put the nonce value to that, the browser will trust that you have put it because it has been generated by the backend. Think of this one way. This is just a stamp of authority to every JavaScript reference in your page. Something to say, this is what it is. This is trusted, go and download. So if you have put that, that whole jQuery.min.js or something like that, it will just go and download it as long as that stamp of approval in the name of nonce is present. If it is not present, it's not going to load it. That's simple as that.
Okay. Is it possible for an attacker to view the nonce just by inspecting the HTML?
The attacker has to be able to break into the traffic that is going between the backend to front end to be able to inject it. Further, there are two things the attacker should be able to do. First, break your TLS and be able to be a man in the middle attack. So if they can do a man in the middle attack, then they can have an access to the header. Because remember, the nonce value comes both in your header as well as in your page. They both have to match. So you have to go ahead, break the communication, do a man in the middle attack, change the value, the header, and then change the same equivalent value in the data field as well to be able to inject whatever script that you want. So there are different techniques in which you can try to figure out. We'll discuss about it a little later. But at this point, you'll have to be able to break your transport layer security if you have any to be able to man in the middle to be able to change it. There are two places you have to change to get it successful.
Okay.
Any other questions? Does hash-based CSP work in a similar way? Exactly. But the difference between hash and nonce is that hash is pre-computed hash value of that particular script. So if you make a minor change to the script, you have to change the hash value again. So it can be cumbersome in some scenarios, but there are cases where you say you're in a legacy application that does not have capabilities to generate nonces, or it's too difficult to do it, you can rely on a hash. Now, this hash value for the script that we're talking about is a hash of the whole script. It is different from sub-resource integrity. That's a very different concept. I'll talk about it a little later because it'll start confusing too many things at the same time. So let's just park that and just deal with scripts and nonce.
When does the nonce change for run?
Nonce can change. So again, it's similar to CSRF. So nonce values typically can be generated per page that's being loaded to giving you better security. So the HTTP header is CSP header specifically is always associated with that particular page. That's why you see that they provide you a capability to provide the HTTP instead of HTTP header provided in the HTML itself, the CSP policy. That's what we saw before, because they are always in conjunction with one another. So for a particular page that is loading, its corresponding nonce values are generated and put as part of the header itself. So to have a successful nonce implementation, if that's what your intention is, then you'll have to be able to generate that on the fly, insert it to the header, insert it into the page. Both has to be happening. Yes. Anything else?
Yeah, Varun, I actually haven't seen this before. So is it for the nonce, would it be the same pattern as a CSRF token that you'd either set it on a per session or per response basis?
Yes, so you could, typically this is generated in most implementations. If you use any CSP generator that automatically creates the nonce for you, they do it per request. Every request that comes in generates a random number and puts it in. You can, I haven't seen anything that actually does it per session, because CSPs tend to be very specific to a page. That value that you want to generate is specific to a page. So they don't really work like CSRF, because CSRF is a little bit more generic. It is more to do with how you deal with sessions. This is to deal with specific pages. So it kind of has one generated for that particular page. And it's
or the hash for the page. Yeah, okay,
exactly.
cool.
It's absolutely no use, because it's a client-side protection. You don't have to retain this value in the backend. That makes no sense, because it's not needed. It's only for the browser to compare the header on this.
Yeah, you need no state table. Yeah, okay, cool. Yeah, I didn't know about this. It's cool.
It's really cool, and it's really effective to do it. If done correctly, people don't like to do it because it's like, oh, token, it's a lot of work. But it's once you do it, it works really effectively.
You can really make, like, if you're writing a payload, like an XSS payload, you can really make the life of the attacker super hard by using this effectively, because you're really limiting the attacker and what they can execute. It's really cool. Especially if you create a simple application that is vulnerable to XSS and you use these headers, you can really see how effective it can be.
Yeah.
Just so I understand this correctly, so this is similar to CSRF, where you like insert a value into the request, like into the returned request, but instead of putting it in the form, you put it on your script tags, so that you can't like insert your own script tags, otherwise they won't get run.
Correct. It's not, remember, it's just not scripts. Scripts are the easy one to explain, but every element of that, like for example, CSS that you're loading, everything can be controlled. So nonce is, but you don't have to generate separate nonce for every element in it. Suppose you have 10 scripts and 3 CSS that you're loading. You don't have to create nonce for every single thing. You need only one nonce generated for that page that you use in all those elements of your page. So everything can be controlled through that.
Right.
It's really it's really what Varun said earlier on, which is you really give, as the creator of the page, right? Like I'm the web server, I create the page. I say on every like piece of JavaScript and CSS, I say, I give approval that this is allowed to be loaded in this page. And that's really what you're doing. And then the minute you have XSS where somebody's injecting code into your page, that stamp of approval is no longer there. So the browser will say, hey, the stamp of approval was not provided. I'm going to reject, like I'm not going to execute this code. Whereas with CSRF, basically what you're saying as the creator of that page is like, hey, any request that comes from this page, just give me this additional token. So I know for sure that the person who I gave this page is also making this, like is making a request back to me. So it's really to tie that page to the user. So that, I think those are the major differences. Does that make sense?
Yep.
Kind of. What I don't understand is what stops me from just reading what the nonce is for a different script tag and then using it in my own.
Okay, so for that, I would like to understand how would you do that. So now let's talk XSS, simple, right? Let's just go to XSS. So you are an attacker and you want to execute your JavaScript on somebody else's browser. So for that, you write a script, something dangerous.js, and that's the payload you craft in a malicious email. You send it to the victim. The victim clicks on it, And when the victim clicks on it, the page loads. And now the page loads with your JavaScript that just got reflected. But when it's getting inserted into your DOM, the browser looks at it and says, hold on, there is a JavaScript over here that does not seem to have any nonce value. And so I will not execute it. So how will you as an attacker know what the nonce value would be generated for that user when they run your payload?
Right. That makes more sense now. Thank you.
Yeah.
Keep in mind, right, like all of these headers are enforced before anything else really starts running on the page. So your code won't run because first it will process all your CSP headers, even some of the X-frame headers that we saw earlier on. Like all of those are processed first before the rest of the page gets rendered. So you're really saying like you have no, unless like for instance you break TLS, you have no real ability to see that nonce before it reaches your page, and by then the CSP header is enforced, and whatever you're injecting that is planning on reading out that nonce will never get executed.
Yeah. There's a question, is this the latest technology? No, CSP has been around for some time. It went under lots of different iterations over a period of time. I think now we are at CSP version 3. I just want to point it out because that's actually a really good question. When implementing CSP, or its biggest drawback has been the lack of support of the standard properly across browsers. 2 browsers that stand tall in this are Chrome and Firefox. Other than that, it's pretty abysmal with all the other browsers, which are rarely good at supporting CSP and all its latest features. CSP v2 is one version that is universally supported across all the browsers, and that would definitely work good. But I can't, at the top of my head, be able to tell you whether nonce is a feature that is there in CSP v2. Probably not. I just don't catch me on that. I can't remember which standard comes through. So the v3 is the latest, and it works with any Chrome or Firefox, the newer ones. But the standard itself is never fully implemented in any of them. They're getting implemented slowly as releases come by. Because of that, when as a developer, you're sending out a productionized code, you're going to experience people who will have CSP v2 support, some will have CSP v3 support, or level 3 support as it's called. So you're going to have different things. So your header will get a little bit more complex. You have to have backward compatibility to support in scenarios in which that does not work, like nonce would not work. And then you can't have people not execute or run any of these scripts altogether. So that's where things get tricky, and why you don't see CSP widely adopted. There are ways. Google has given lots of documentation around it, but people are like, but that's a lot of work. And that's the reason the adaptation is low. But this definitely is the most effective that we have right now. Someone asked, does CSP have a good adaptation? If someone has a really good CSP header that is effective, that means they are a very mature company. Most companies do have CSP headers, but they have poor implementation of it simply because they wanted to allow far more flexibility than what CSP is allowed to. You can write the shittiest CSP header with 0 security, or you can write the strongest. You can do a lot with same CSP headers. So it depends upon how it's configured. And that shows the maturity from the company that you're dealing with. So like we just talked about, no inline code. If you have any inline code, that's one of the common things that you see with CSP. They say by default, you should not be able to run inline code. Now, if you want to run inline code, you have to use something like nonce that we just discussed. But however, if you do not want to go into all this nonce thing and you want to go into more static-based CSP, which means there's no nonces, but you still want to whitelist it. Say you do not have hundreds of domains, right? You have like one JavaScript that is coming from, say, jQuery.com. I only want to whitelist one. I don't care about nonce really. And that's fair. I mean, everybody has their own capabilities. So in that case, you skip nonce and stuff like that and just deal with it with a more strict JavaScript, CSP header. In that scenario, you can't execute JavaScript by default. in it. So you'll have to move your JavaScript code into .js files and load it. And as long as the JS is coming from your whitelisted domains, we looked at it, and that could be self, or it could be coming from somewhere else which you whitelisted, it's fine. Another way is to have a hash value, like you see, SHA value that you see over there, that has to be present in your header as well. These are static, they don't change automatically. But the moment you make changes to your HTML file and the JavaScript gets changed, the hash value changes again. So development wise or building wise in automated CI/CD pipeline, that's a nightmare. You just do not want to do that. I've not seen anyone successfully do it, to be honest. But it is okay in a scenario where you know some legacy code, you never touch it, never change it, and it has some JavaScripts there which you want to execute inline, then use a SHA. Another aspect, now what we looked at is one aspect of CSP. Then there's also other places where you can trigger XSS, that is with respect to events, event triggered JavaScript. Like for example, on click do something is a JavaScript function. And these things are also strictly stopped by JavaScript. And if you have a code that looks like button ID equal to on click do something, that's no longer allowed. You'll have to add it through an event listener where you specify the event on which is being done. So these kinds of code changes that you need to make in your backend typically is also one of the reasons people do not want to change, because they think that this will break something. But these are effectively better coding practices that one needs to follow. If you're writing a brand new application, you really have no reason to do that. But if you're changing a legacy to this, that's a more difficult proposition to ask people to change that. So that's the challenge I face when I discuss with this with most developers. Any questions at this stage? Okay, so that's a good question. So like we just discussed in the previous example, we said there is no inline JavaScript. The same concept goes down over here as well. The do something is essentially an inline JavaScript call, and that's essentially not allowed. So the second one is essentially registering a function that is do something, and it's not something that you directly call inline. It's a function that you register with, and then you can just call it through your extended .js file. I'm going to just show you that particular example. So again, this is a demo that I wrote simply to showcase this. It's not very nice, but bear with me with what I have. But I think it gets the point across. That's the main thing. Yeah, that's my function. So I does not have a lot of things, but it has something very important to look at. So this is my default page, I think, when it loads. And I'm going to show you the source code. It's as simple as this. So what you see over here is hello world. That's just the header. But then you see this console.log hello world. And if you come over here, you see that it never got executed, that hello world. That's because this is an inline JavaScript that should not be executed, as we just discussed. So, however, you see that I'm also having a function, JavaScript here that's been moved to a different file, .js. So if I move this code into the JS file, it will execute. So let's look at that. So if I do this, say I copy this stuff and move it here, I just don't need the script tags and all anymore. Ah, that's good. There you go. Hello world gets executed. All I have to do is just move them aside, and it'll automatically get executed. At this point, I'm not using nuns, none of that stuff. I'm just using this basic thing. Now you're wondering why and how that works. Now let's look at the header. And I want you guys to look at the header and tell me what you're seeing. The header that I'm using is fairly straightforward header. It says default source is self, script is self. What did I say? Any script is a lower directive, so it automatically take it. So as long as the JavaScript is coming from my local host 5000, it's going to work. Anything coming from outside of it, it will not. That's the reason there was no problem in loading this move.js. It got loaded into my JavaScript, and that's why you saw that execution happening. So that is an important point to consider. Another thing is look at this functionality. Now, I just talked about when you click on the button and you want to do something. Now, we said that this is not an effective solution. And instead, I said that it has to be put up over here. Yes, so it has to be put up over here in this JavaScript. So that will typically be the right way to do it. Now, for example, I will just remove this. So if I remove this, all I have over here is a fairly simple, straightforward thing. It's just having the bare minimum, and that means it's going to do, when I click that button, it's going to do something. It's going to execute. That's my hope, at least. So for that, I have to make sure that this is enabled. So that's a inline JavaScript. And if I try to execute this, you see this, oh, sorry. This is coming from cache. Yeah, there you go. So it says it's refused to do that because it found that that particular file is not supposed to be executed because it is it's coming from an inline JavaScript. So I have, in order to get this working, I'll again have to move something like this straight into here. And if it is registered to execute from here, that will succeed. So over here, let me remove this code. Yeah, and you, did I not get that working? I thought I did. Oh, sorry, still commented out. There you go, clicked. So that keeps working now. So this is the sort of changes that you need to be making in your code to get CSP working correctly as per what you need. The other thing that I really want to showcase here is the aspect that is probably the most important one, in my opinion, at least, is CSP violation. Now, if you notice my header that I sent across, there is one important thing that I had: report URI equal to CSP violation something. So this is an endpoint I'm providing my CSP header to say anytime there is a CSP violation and an attack has happened, report that back to me. And that CSP violation is important because it gives you the details of that particular attack. So when the when the CSP violation happened, when I had the JavaScript execute without a nonce value, or it's statically present there, which executed, it generated a CSP report. And this is done by the browser, and the browser generates a report that clearly says where the document URI is, what is the thing that broke this directive. It shows that there is the source element that broke this directive. And typically, this sort of information is really, really useful. There are two aspects to it. If you log this in your backend, you kind of know what are the attacks that are happening on your systems that failed, that what are the attack. Now, there's also another use case. I've seen a lot of developers starting to use this in a report-only mode to run their functional test cases with different payloads of XSS against their application. And if any of those XSS payloads succeed, they will get a report, and thereby they can fail the test case that for this particular page, for this particular field value, form value, if this particular payload seems to be succeeding. So that is a very effective way to automate a lot of your XSS test cases if you have one. So it's a really, really cool option to do this. So does that make sense? Is there any question at this point? Sorry.
The report URL is really, really cool. That I learned something today.
That was a really, really good one. I starting to use quite a lot, and you can do quite a lot of funky things with it if you start using them. I would recommend people to, if you guys end up being developers, you'll be really cool developers if you start writing test cases like this. Like all your granddads that you'll meet there in the corporate world will not know about them. So,
like me. No, it's really cool because even if you're like in a detection team and get visibility over this, you can really start identifying like super unique cases or pages that are being executed, and you can probably start identifying pages that are vulnerable to XSS while people are like trying out their like finding their bugs. So while people are trying to write their exploits, you can probably start spotting them on a page. That's really cool.
Yeah, it is. I really like it. I use it quite a lot. So hopefully everybody picks up and start using them. I think it'll be very, very good.
Won't you only be finding the ones that fail though, and the ones that violate the policy?
Correct. So that's what you want as well, right? The aim is to see when will the violation happen when something successfully executed. So you have a payload that successfully executed. You want to know what payload successfully executed in yours. So that means a malicious payload was able to succeed, and that generated this violation for you. So that means your code, which is supposed to take care of all your encoding and all, is not doing its job. So you know where it is. So if you want to effectively use CSP, the best thing is to move all your scripts from inline to external JavaScript. That's the cleanest way to do it. The only reason is legacy if you want to keep it inline. And if you're using inline, try using nuns. That's the best way to migrate. You can always also use SHA values. I really discourage that. I've seen in the past in real life that wherever I've recommended, people came by saying this is a nightmare. So don't. So personal experience, it never really worked. Regenerating nuns for every page is really helpful because it's difficult to guess. And these are usually cryptographic functionalities of random generation. Chances of you getting the same nuns is really, really low. I'm not a cryptographic expert, but my guess is that, yeah, I mean, someone attacking you through that is very, very low. Nonetheless, this again is an extra layer. You still have to do your validations. You have to do all those techniques that we discussed from a defense perspective, and that does not change. CSP is not one fix for all. It is something that helps you. It's definitely an additional layer, but if you have a shitty code below it, a small change or a small badly configured CSP policy will just make it completely useless. So that's something.
If you have CSP, does that mean that you don't need SOP?
No, same origin policy is something that the browser implements, and same origin policy has nothing to do with any of that. Same origin policy is to ensure that the contents are loaded from the same origin. Now you're breaking all that in all the different scenarios we talked about when we're trying to load a script from some other source and location. And same origin policy does not actually do anything with respect to what can execute and what should not execute. CSP is actually more fine-grained into after the loading of the resource, what should execute or not. Same origin policy is purely about what can be downloaded, what can be uploaded. That's pretty much where it stops. But this will go into telling that when can you insert into the DOM? Can you or can you not? Are you allowed to insert into an iframe or not? Are you allowed to load an iframe or not? All that controls is not something same origin policy can do much about.
Right. So if CSP stops things from actually executing,
yeah,
doesn't it not matter whether you load them or not?
So there are two aspects to it. So you, as a page, if you say script source pull this, you're supposed to load that script because that is part of your HTML standard to load that particular script. However, what you do with it is determined by this policy pretty much. Whether should you execute it, should you prevent it from loading, that's controlled by this particular policy. So what you're asking is like, same origin is one step withdrawn from this. This is finer grained control. So what we're talking about the same origin is pretty much ensuring that the origin from where you're loading any resource for your application is your same origin. Now, we also talked about that you can load from other origin using CORS, right? So same origin simply falls flat the moment you have a CORS header. So what if an evil.com has CORS header, and how do you prevent that from loading? It's going to load. Does that make sense?
Yeah, but what I don't quite understand what same origin policy stops from happening that CSP on a higher level won't stop anyway.
So, okay, don't take those two into two separately. They work in conjunction with one another. So same origin policy is like a default rule a browser follows with respect to loading a resource. Same origin policy is simply does not depend upon what security headers you have in place, how you configure a system. It does not care how your backend is supposed to be. It just follows that rule for every backend it connects to. Okay, so now
right.
take that.
But
now,
I would still need to include the same origin policy headers in my requests.
You mean CORS headers?
Yeah, sorry.
Yes, CORS headers you still have to, because all that CORS headers does is, so within CSP, you can also specify where you can load some resources or not, but CORS header is typically another rule within the browser, which does the same origin validation that determines whether this is allowed or not. So typically say, let me put it one step behind. Irrespective of what you have in your CSP, if your same origin policy header, that is, as you call it, CORS headers, typically says you can't load this resource on this particular page, right? So that simply means that the browser will not even go ahead to load that particular, so it'll just block it from loading. It's one level higher. CSP is after the browser accepts that, what do you do with it? Two stages. So CSP does not come into effect. And CORS headers are crucial because not everyone is going to have a CSP header. If they do not have a CSP header, what is there that is probably preventing you from following these basic rules of HTTP, of the browser server communication?
So
right.
I'm gonna try and I'm gonna have a stab here at like CORS policies or same origin policies. Basically say, where can this page be loaded?
Mm-hmm.
And then CSP says, once this page is loaded, where can additional resources be loaded from?
Right, I see. Okay, cool.
Right? So
yes.
It's really about, like, CSP is really to help you protect the page that you just loaded. So it's really, it's almost sandboxing your content. And basically saying like, I'm only gonna allow outbound requests from this page to myself and to bootstrap.com, where same origin policy will basically say this page can only be, I feel like I'm losing my own chain of thought. Like this is complex, like this is like, but basically saying this, you can load this page here.
Yeah, yeah.
I might have made it more complicated now, which
No,
that would not be good.
The first part you said helped.
Okay, good. I'm glad. I'll stop talking then.
All right.
Thank you.
So when we just discussed clickjacking a little while ago, we said those headers are getting deprecated and they no longer, and they will go away eventually. But the reason being that CSP is again having a lot of power under it, which you can control. And CSP has something called frame ancestors, is another directive, which has exactly the same thing that you see before. You can say no framing, or you can say framing only from self origin, or set the set of origins ancestors that you can provide, which can frame their frame those contents in these places. So it's exactly the same as the previous header, except that it's now all put to CSP. So you are sooner or later, as you guys mature into this field, you're going to see all these additional unnecessary headers going away and then converging into one single header that will be effective. Hopefully that's the dream, unless someone comes and says, oh, we have another fantastic new header, forget CSP. I don't know, but that has happened before. So don't be surprised if that happens in the future. There is obviously quite a lot of people who are not necessarily satisfied with CSP. They find it too complex. So you always have the two things. You have the finer grain control, which is great, but if done wrong, can be disastrous. So, and I have a bunch of stuff that is worth going. I have to admit one thing. When I did these slides, I had to do it based on, so that I don't put two heavy topics together. But one thing I missed, unfortunately, is the reading material. They had to be swapped with the previous thing. I forgot to swap them. The last XSS thing had all these materials, clickjacking and stuff. And this has all the XSS material of the previous week. I'm really sorry about that. I only realized it today that I forgot to swap those two. So if anyone are looking for references and places that you want to look, that's something you definitely want to check it out. At this point, any questions do you guys have for today? Or I have a few announcements later though, if there's no other questions. Okay. We came to realize this thing that some people have been struggling with XSS challenges that has come through, and we can understand it was never meant to be so straightforward, and probably that is the part of learning. But our intention is not to make you not get flags. That's just not what the intention is. So we're planning to come up with a few common examples and use cases and hints. We'll try to make the hints a lot more straightforward than we did for SQL injections, which means most of you, if you read the hints correctly, should be able to solve it. And I think most of you are already aware that in order to get the actual cookie, you need an endpoint listening for these to be executed. I think you're aware, given some of you have already solved it. But in case others are wondering why you're not able to see the flag when you execute locally in your laptop, that's because it does not work that way. You have to steal the cookie from someone else executing it, like the real XSS scenario. So that's where that button that you have, click for admin, the complaint to admin or report to admin, that button plays an important role in that scenario to get the flag. And also one very important hint there, whatever that particular button does, pay attention to that, because you can change those endpoints to something else to get your flag. Just saying, that's also a hint that you need to take into consideration. We are going to go ahead and give those hints out soon. So there will be some challenges coming up this week as well. There are a few, but those challenges are going to be very different from what you're doing. These challenges, I guarantee you, will be definitely much easier. And I'm thinking 95% of you will get those flags for sure, because they are seen from a defense perspective. This is the first few things that we are trying out to see how you do it from a defense perspective. And so definitely go give it a shot. I don't know that it's already released. I think it is. If it's not, it will soon be. And they are easy. And the only thing to get to succeed in that is to go through the concepts we just discussed, and you will find most of your answers quite easy to solve. Any other questions? It's been 20 minutes over time, so sorry about that. Sorry about MasterChef as well.
Okay, 10 more minutes till MasterChef, I think.
Okay.
Yeah. So no new challenge this week?
We do. We are. I think it's already released. I think. Is it, Adam?
Which challenges you are talking about?
ESP challenges.
Sorry?
ESP challenges.
CSP? They got released together with last week's ones.
Yeah, so it's already released. So it's all there. So nothing newly getting released, but it's already released as part of the last week. I didn't know it was released last week, so sorry. Any other questions, guys? If not, thanks. Thank you, everyone.